All right, hello again, 8th grade math folks. Today we're going to talk about proving figures congruent and also take a look at some other transformation practice as we continue along here in the transformations unit. So some vocabulary here for the very first blank up here on top of your notes here. If a two-dimensional figure is mapped to its image through a sequence of rigid motions, is what goes here, then the figures are congruent. Congruent means that they are the same size and the same shape, and there's a symbol. This is the symbol for congruent, okay? And rigid motion could be a translation, rotation, or reflection, because all three of those transformations preserve size and shape. That's what we're talking about here in this part of the unit, rigid motions. So as we look at this first example, I'll also remember here to point out that these notes are available in Schoology, and you can edit them through Kami, or you can print them off, or whatever you want to do. But as you're watching this video and these examples, you need to fill out your notes, because then you'll be asked to finish it up and turn it in. So the more you can do along with me while I'm going through some of these on this video, the less you'll have to do on your own. So here's the first question. Describe a series of rigid motions that proves ABC is congruent to EFG. So we're trying to show that this triangle is congruent to this triangle, and we're trying to do that by mapping ABC onto EFG. Now the order of these letters matters. I want A to go to E. I want B to go to F. And I want C to go to G. The order of the letters matters. So how could I get ABC oriented the same way as EFG? Well, I'm going to try a reflection about the y-axis first. So if I reflect about the y-axis, let's start with A. 1, 2, 1, 2. So A prime would be right here. B prime, 1, 2, 3, 4 to get to the y-axis. So 1, 2, 3, 4. Here's B prime. And C prime, 1, 2, 3, 4. 1, 2, 3, 4. There's C prime. Now if I connect those, I get this triangle right here. Now I'm getting really close. Think of that transformations golf activity that many of you tried, mapping one figure onto another. Think about what you would need to do here. Well, from this point, all we need to do is slide. We need to slide 1 to the right and 3 down, and that'll get us right on top of EFG. So then what I would do is I'd come over here and I'd say, all right, well, let's describe a series of rigid motions. Well, step 1, reflect over y-axis. That's the first thing I did. And then the second thing I'll need to do is translate, but I'm going to need to write the rule, won't I? Translate 1 to the right, so that's x plus 1 if I'm going right, and 3 down, so y minus 3. That would do it. Now you may be looking at my answers saying, well, I did it a different way. Well, that's fine. There's lots of different ways to map these two triangles onto each other. This is just maybe the most straightforward way and the way I showed you, but maybe you did it a different way, and it's probably still correct. Here in example 2, I want to map ABCD to WXYZ. I need to get A on W. They're both the first letter. So think about orientation here. If I just translate, is A going to match up with W? No. If I just translate this thing to the right and down, A would match up with Y. That's not going to work. So I need to reflect first. And if I reflect over the y-axis, there's B prime, there's C prime, here's D prime over here, here's A prime up here. If I connect those, now I'm getting closer. Now you can see here that I just need to shift A. I need to get it down to W. So if I did a translation here, would that get A to W? No, it would match A to Z. So I'm still not quite there, but I'm getting really close. What if I did a reflection to match A onto W? If I did a reflection, I could use this line right here as a line of reflection. This line right here, if I use that line as a line of reflection, can you see that if you flip over that mirror image, we'll call this line L. If I flip over line L, A would land right on W. And then it would match up exactly how we want it to. So here's what we could say. So the first step was reflect over y-axis. And then step 2 was reflect over x-axis. Can anybody figure out a shorter way to do this besides the two-step reflection, the double reflection? Perhaps you remember that a double reflection over the x and the y-axis is the same as rotating 180 degrees. So if you just rotated the original 180 degrees, that would get you there in one step. Skipping ahead here to page 3, these are both challenge problems. They're both keyed on the key that's available on Schoology. I'm not going to go through and show you these. These are more of a challenge if you are looking for a little extension after you've completed the packet. Again, this page is not required for everybody, just as a challenge. All right, now I'm on page 4, practicing translations a little bit further. We're given a rule here, a translation rule of x plus 4, y plus 2. That means I need to move every point here 4 units to the right, which is the positive direction on the x, and 2 units up. So if I do that, let's see what happens. 2, 3, 4, 1, 2. So L prime would end up here. K, 1, 2, 3, 4, 1, 2. There's K prime. Starting at J, 1, 2, 3, 4, 1, 2. There's J prime. Connect those 3 dots, and I have my congruent triangle. Now where do those points end up? Well, I could just look at the coordinates. So K ended up at 2, 0. Here's K. K is at 2, 0. K prime, I should say. K prime is at 2, 0. And where did L land? L landed up here at 5, 4. So L prime, 5, 4. Now another way you could have figured out those new points is you could have taken the original points, which are right here, and just applied this rule to it. So x plus 4, y plus 2. So if you look at this point right here, x plus 4, so negative 2 plus 4 equals 2. And then if you look at the y coordinate, negative 2, if you add 2 to negative 2, negative 2 plus 2, you get 0. So you could have applied the rule and gotten the points that way as well. There's a question below there, is the image congruent to the original figure? Yes, they're congruent. It was a rigid motion, right? A translation's a rigid motion. Triangle JKL is congruent to triangle J prime, K prime, L prime. All right, let's look here at page 5. You're given 2 images, 2 figures, and you're asked to state the rule. So notice that the black one is the original, the blue one is the image, the result of a transformation. So what happened here? Well, if you look at Z, for example, what happened to Z? It went 2 to the right and 1 down. If you go to K, 2 to the right, 1 down. Go to I, 2 to the right, 1 down. So how do I show a rule that says 2 to the right and 1 down? Well, you show that by saying x plus 2, right, because the right is positive, and 1 down, so y minus 1. That would be your rule for that one. What about number 6? The original is the black one again. Let's go to J. Left 1, up 1. V. Left 1, up 1. Left 1, up 1. Left 1, up 1. So that's the rule, left 1, up 1. How do I say that? Left 1, so x minus 1, and up 1, so y plus 1. Number 4 here on page 6 asks us to reflect over the line x equals 2. Well, where is that line? X is this axis right here. X equals 2 is right here. So x equals 2 is this line right here. So that is my line of reflection, x equals 2. So let's conduct our reflection. S is 2 away from it, so you go 2 the other direction. Here is S prime. A is 1 away, so A prime is 1 away the other direction. J is 2 away, so J prime is 2 the other direction. There's J prime. T is 1, 2, 3 away from the line of reflection, so 1, 2, 3 the other direction. There's T prime. And there's my figure, reflecting over the line x equals 2. As a hint, what if it said y equals 2? What would that line look like? This isn't a part of the problem, I'm just pointing it out. If it said y equals 2 instead of x equals 2, y equals 2, here is 2 on the y-axis right there, that would be y equals 2. So if I said reflect over y equals 2, you would reflect over the blue line, not the black line. Last thing to talk about here is reviewing rotations. So remember the rules. These rules are pretty important right here, and you're going to want to memorize them. For 90 degrees, it's opposite of y, comma x. So that's what we're doing here in this first one, opposite y, comma x. So when you do that, For A prime, opposite of y, so there's x, there's y. Opposite of y would be -5, and x is 3. So there you go. And B prime, opposite of y, so that's -3, and y is 2. For C prime, opposite of y, so -1, and x was 4, so that's where that goes. For 180, my rule is opposite of x, opposite of y. So you're just negating the signs for all these. So A double prime is -3, -5. B double prime is -2, -3. And C double prime is -4, -1. Of course, you would have to plot those 3 points and connect the dots to form a figure. 270 is y opposite x. That's the rule. So for A triple prime here, y is 5. The opposite x would be -3. For B triple prime, y is 3, so it stays 3. Opposite of x is -2. And for C triple prime, y is 1. Opposite of x is -4. So that's how you would conduct the points. If you can get the points, then you just have to plot them, and you would get 4 different figures. You can check out the key to see what it should look like when you're done plotting. The bottom of the previous page and this page are just practice. Please complete, check the key. Let me know if you have any questions. Thanks for watching, and I'll see you next time.